Welcome everyone to AI on AI, the podcast where we decode the future of intelligence, one algorithm at a time. Today, we're diving into a really fascinating paper called ZEROSERCH, which proposes a way to teach large language models, or LLMs, how to search for information, without actually searching in the traditional sense. It's a bit of a mind bender, and we've got a stellar panel of experts to unpack it. Let's start with our expert in AI business strategy. From a 30,000-foot view, why is improving an LLM's search capability so critical for businesses today?
Thanks for having me. Well, it's fundamental. LLMs are powerful, but their knowledge is static, frozen at the time of their last training. For businesses to rely on them for real time decision making, customer support, or research, these models must access and use up to date external information. The problem is current methods like retrieval augmented generation or RAG often involve interacting with live search engines, and that gets expensive and messy fast.
A very relatable analogy. Our expert in reinforcement learning, can you give us the elevator pitch for ZEROSERCH? How does it propose to solve this pricey problem?
Absolutely, the core idea of ZEROSERCH is, well, quite ingenious. It's a reinforcement learning framework that trains LLMs to develop search strategies without constantly pinging real search engines. Instead, it uses another LLM, a specially fine-tuned one, to simulate the search engine environment. Think of it as a flight simulator for LLMs learning to navigate the information landscape.
A flight simulator for LLMs, I like that. Our expert in retrieval augmented generation, you know the pain points of current RAG systems. The paper highlights uncontrolled document quality and prohibitively high API costs. Can you elaborate?
Precisely, when an LLM uses a live search engine during training, the documents it gets back can be a mixed bag, some relevant, some noisy, some outdated. This unpredictability makes the RL training process unstable, like trying to learn to cook with ingredients that randomly change quality. And the API costs, oh boy. RL training involves hundreds of thousands, even millions of interactions.
Our expert in AI industry applications, have you seen these challenges play out in real-world projects?
Definitely. I've seen projects hit significant budget overruns due to API call volumes during the RAG system development and tuning phase. And the uncontrolled document quality isn't just a technical nuisance, it directly impacts the reliability of the LLM's output. If the LLM learns from noisy search results, it will, in turn, provide noisy or incorrect answers to the end user. This undermines trust, which is a huge barrier to adoption for business applications.
So ZEROSERCH proposes using an LLM to simulate the search engine. Our expert in LLM architecture, how exactly is this simulation LLM created and what does it do?
It's a clever bit of engineering. They take an LLM, and the paper shows this works with models as small as 3B parameters, and perform a lightweight supervised fine tuning SFT. This SFT teaches the LLM to generate documents in response to a query, much like a search engine would. Crucially, they fine tune it to generate both relevant, useful documents and noisy, unhelpful ones by slightly changing the prompt during this SFT phase.
And how does this controlled, simulated environment then help train the main LLM to search better? Expert in reinforcement learning, the paper mentions a curriculum-based rollout strategy.
Yes, that's a key part. Instead of just throwing the policy model, the LLM learning to search into the deep end, they use a curriculum. Initially, the simulation LLM is prompted to provide mostly high-quality, relevant documents. It's like teaching a child to find things in a very organized room. As the policy model gets better, the curriculum makes the task harder by increasing the probability of the simulation LLM returning noisy or irrelevant documents.
So it's like gradually increasing the difficulty in a video game to build skill. Expert in RAG, what about the reward mechanism? How does the LLM know if it's doing a good job searching and answering?
The paper states they use an F1 score-based reward, focusing on answer accuracy. This is a smart move. They found that a simple exact match M reward could lead to reward hacking, where the model might generate overly long answers hoping to stumble upon the correct keywords. The F1 score, which balances precision and recall, encourages more concise and accurate answers.
And there's a detail about loss masking for retrieved tokens. Our expert in reinforcement learning, why is that important?
Yes, during the RL update, the policy model is learning from the entire interaction sequence. However, the documents retrieved from the simulation LLM are not generated by the policy model itself. They're external inputs in that context. Applying gradient updates to these externally generated tokens can destabilize training.
Let's talk results. The paper claims some impressive figures. Expert in LLM architecture, what stood out to you from their experiments?
The results are indeed quite compelling. ZEROSERCH, using a 14B parameter QN model as the simulation LLM, actually surpassed the performance of a baseline that used a real search engine like Google. That's a big headline. Even a 7B simulation LLM was comparable.
Expert in AI business strategy, zero API cost, and potentially better performance. That must sound like a win-win. What are the business implications if this holds up?
It's potentially transformative for democratizing advanced AI capabilities. If you can achieve state-of-the-art search-augmented LLMs without incurring massive ongoing API expenses, it opens the door for smaller companies, researchers with limited budgets, and even on-premise deployments where hitting external APIs is a no-go. It means more innovation, faster iteration, and potentially more reliable AI products because the training is more controlled.
Our industry applications expert, how does this compare to other advanced RAG methods or RL tuning methods you've seen?
It's a significant step. Many advanced RAG methods still grapple with the cost and control issues if they rely on live search for grounding or continuous learning. RL-tuned methods like Search R1, which ZEROSERCH compares against, show promise but hit that API cost wall. ZEROSERCH's approach of internalizing the search world through simulation offers a different paradigm.
This concept of an LLM simulating a search engine is central. Expert in RAG, the paper shows that fine-tuned simulation LLMs significantly outperform simple prompt-based ones. Why is that?
While simply prompting a generic LLM to act like a search engine might get you part of the way, but there's often a style gap, as the paper calls it. Real search engine results have a certain structure, density, and type of noise. The lightweight supervised fine-tuning allows the simulation LLM to much more faithfully mimic these characteristics, including the ability to generate plausible, noisy documents on demand. This fidelity in simulation is crucial for effective curriculum learning.
And building on what our RAG expert said, the fact that a 3B or 7B parameter model can be fine-tuned to be such an effective simulator is itself a testament to the power of these architectures. It's not just about scale, it's about specialized adaptation. This SFT process is lightweight, meaning it's not another massive pre-training effort.
Now I want to bring in our contrarian expert. This all sounds great, almost too good to be true. ZEROSERCH. But are we truly at zero search cost, or are we just shifting the burden?
That's the million-dollar or perhaps multi-GPU question. While it brilliantly sidesteps API costs, it introduces the cost of running this simulation LLM. The paper itself notes this. Deploying the simulated search LLM requires access to GPU servers. They provide a cost analysis showing it's still cheaper than API calls, and I appreciate that transparency, but it's not free.
I see your point, Expert 6, but I'd argue the control and predictability gained are worth a lot. Plus, the paper suggests sharing a single simulation server across multiple RL training tasks, which could amortize those GPU costs significantly. It's about total cost of ownership and development agility.
That's a fair counter. Our expert in future AI implications, what about the quality of this simulation? Can an LLM, however well fine-tuned, truly replicate the dynamic, ever-changing nature of the real web or a massive enterprise knowledge base?
That's a very pertinent question. The current simulation seems focused on mimicking the style and relevance noise distribution of search results for question-answering tasks. For now, it proves remarkably effective. However, the real web is adversarial, constantly updated, and contains formats beyond text snippets.
An excellent point. It makes me think of Goodhart's law. When a measure becomes a target, it ceases to be a good measure. If the simulation becomes the sole target, are we optimizing for a proxy of the real world?
Exactly, and another thing, the paper focuses on generating useful versus noisy documents based on whether they lead to correct answers for the training questions. But usefulness in the real world can be more nuanced. What if a document is factually correct but unhelpful for this specific user's nuanced information need? Or what if it's slightly off but sparks a novel line of inquiry? The binary useful-noisy distinction, while practical for training, might oversimplify.
This curriculum learning aspect seems vital. Expert in reinforcement learning, the study comparing easy to hard versus hard to easy curricula was quite telling.
Oh, absolutely. The reverse curriculum, where training started with difficult, noisy searches and then got easier, performed significantly worse. This underscores a fundamental principle in learning, not just for AIs, but for humans too. You build foundational skills in a supportive environment before tackling more complex challenges.
Okay, let's shift towards the future. Expert in AI business strategy. If ZEROSERCH or similar approaches become widespread, how does this change the landscape for companies building or using LLMs?
It dramatically lowers the barrier to entry for creating sophisticated, knowledgeable AI agents. Companies that were previously priced out of RL-based RAG due to API costs can now explore it. It could lead to a new wave of specialized AI assistants that are deeply knowledgeable in specific domains because they can be trained to search simulated domain-specific knowledge bases cost-effectively.
Our expert in future AI implications. What are the broader impacts you foresee? Could this change how we even think about LLM training?
I think it could. It points towards a future where LLMs are trained in richer, more interactive simulated environments that go beyond static text corpora. If we can effectively simulate search, can we simulate other complex interactions, debates, collaborative problem solving? It also raises interesting questions about the knowledge within the simulation LLM. Is it implicitly a highly compressed, queryable version of the data it was trained on to mimic search?
Here's a thought that just popped into my head, maybe a bit of a playful jab. Are we heading towards LLMs that are so good at simulating search engines that they start holding internal press conferences with themselves to get information?
Chuckles, well, it's not quite a press conference, but the think tags are a bit like the LLM's internal monologue or a scratch pad. It's a structured way to reason before acting. So in a way, it is having a little chat with itself before deciding what to Google in its simulated world.
I love that. Now, for an element of surprise. Our contrarian expert, while ZEROSERCH solves the API cost for search, what new bottleneck or unforeseen challenge might emerge if this approach becomes dominant?
That's a fantastic question. My contrarian thought is this. If we get really good at training LLMs to search in these simulated environments, the bottleneck might shift to the creation and maintenance of high-fidelity simulation LLMs. Crafting a simulation LLM that accurately reflects a complex, dynamic domain, say, real-time financial news or rapidly evolving scientific literature, becomes a significant undertaking in itself.
A cottage industry of simulation LLM engineers. That's a fascinating and very plausible future. It really underscores that there's no such thing as a free lunch, even in AI. The complexity just morphs. This has been an incredibly rich discussion. We've journeyed from the high costs of traditional RAG to the ingenious solution of an LLM simulating a search engine, the nuances of curriculum learning, and even peered into potential future bottlenecks. ZEROSERCH certainly gives us a lot to think about, reducing costs, increasing control, and pushing the boundaries of how LLMs can learn to interact with information. A huge thank you to our expert in AI business strategy, our expert in reinforcement learning, our expert in RAG, our expert in AI industry applications, our expert in LLM architecture, our insightful contrarian expert, and our expert in future AI implications. Your diverse perspectives have truly illuminated this complex topic. And to our listeners, Thank you for tuning into AI on AI. Join us next time as we continue to explore the cutting edge of artificial intelligence. This paper introduces ZEROSERCH, a new framework. ZEROSERCH enhances search capabilities in large language models. It trains these models without using real search engines. This method avoids high application programming interface costs. It also allows control over the quality of training documents. ZEROSERCH uses a separate large language model to simulate a search engine. This simulated engine is trained through lightweight supervised fine-tuning. Supervised fine-tuning helps it generate relevant or noisy documents. Training employs a curriculum-based rollout strategy. The quality of simulated documents gradually degrades over time. This progressively challenges the main model's reasoning ability. A multi-turn template guides the model to think, search, and answer. The model surprisingly learns to follow output formats. This happens without explicit reward for correct formatting. Answer accuracy is measured using an F1 score. The F1 score balances precision and recall in answers. Loss masking for retrieved document tokens stabilizes training. This ensures gradients only update the model's own outputs. ZEROSERCH works with various large language models and reinforcement learning algorithms. Experiments show a 3 billion parameter model effectively simulates search. A 7 billion parameter simulation model matches real search engine performance. A 14 billion parameter simulation model can surpass real search engines. This approach generalizes well to different model sizes and types. It also shows a more stable learning process than real search. Fine-tuned simulation models significantly outperform prompt-based ones. Larger simulation models lead to better overall performance. A limitation is the need for graphics processing unit servers. These servers are for deploying the simulation model. This incurs infrastructure costs, but less than application programming interface fees. ZEROSERCH offers a scalable way to improve search in large language models.